Dear students, today we learn about the 8086 microprocessor and one of its arithmetic instruction called AAA. That means ASCII Adjust for Addition. Okay, first before you are using this instruction, you need to understand what is the process of this instruction, where we are using this instruction in the program. Okay, first AA instruction should be executed immediately after the add instruction, that add ASCII data. It means it's used after an addition ADD when the operands are ASCII values. So I'll show you the instruction. See, here the AA instruction is used, like I'm going to add this values. You can see the operands are ASCII values. Operands are ASCII values. These are the character. First, you need to understand the ASCII, right? What do you mean by ASCII? That is American Standard Code for Information Interchange. So that will be represent like a, see, these are the valid unpacked decimal numbers like a 0 to 9. So that character 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That equivalent hexadecimal will be 30, 31, 32 to 39. Similarly, the decimal and binary is given. So here you can see the 30 is being added. For 0, the hexadecimal is 30. For 1, the represent in the code that represent the character, the 30. That means for every representation 30 is being added. So that is important to write the code. Okay, so come here, you can see here the 7 is represented by 37 because that is in hexadecimal. So this is code represents the character, right? So 6 is 36. So you can see AA is used. Okay, so I hope you understand. Now, next important thing is here when assume the AL register as a source and destination, there is no operand while you are using this instruction. You can see here. So there is no operand. There is no operand in this instruction, right? That's what they said. The next thing is it used to adjust the result of two ASCII values that range from 30 to 39H after addition. So that's what I said. This instruction will be used immediately after the add instruction when operands are ASCII values. It ensures that the result is a valid unpacked decimal number. If it is not a valid unpacked decimal numbers, after adding this ASCII values, this adjustment will be made. Okay, this is what this instruction is doing. Okay, this condition now you will not understand. I will explain the process in the program, then we will come to this condition. Okay, so that you can understand clearly. Okay, so first, okay, now the AL is loaded with the 37H. Okay, so this is adding with the 36. Okay, we are adding this with the 36H. The current value of AL is 6D, 6DH. Initially it was 0, 0. So before execution of AH is 0. So remember that is very important, 0. Okay, now see this. This is not a valid unpacked decimal because it should be in the range of 0 to 9. So adjustment is required. Okay, adjustment is required because it is greater than 9. If it is greater than 9, what I need to do? I need to add the results with a 0, 6. So you know that the D equivalent decimal value is 13, and if you add this with this 6, so 13 plus 6 you will be getting 19. If you convert into the decimal, if you convert into hexadecimal, what you will get? So so you will be getting 1 3. So 3, if you add along with this 1, you will get a 73. That is the current value. Okay, now very important, you can see. Okay, so see lower nibble will become 03. How? The reason is, see, AH AL. After execution of this instruction AAA, this AH will be incremented by 1, and this 73, right? This the upper nibble of your lower byte will become 0, right? Then only you will be having a valid and packed decimal numbers. Two things will happen. One, the AH will be incremented by 1 and it will clear the upper nibble of the upper nibble of the lower byte. So it becomes 0103. That's what it's shown here. So AH 03 and AL is 03. Okay, so this is a condition you want to understand. Which flag will be updated? Your auxiliary flag and carry flag will be updated. Both the flags will be updated. Okay, the auxiliary carry will be updated because of the carry out of the lower nibble. Okay, your carry flag also will be updated because it requires the adjustment with adding of 6. So it sets the carry flag. Okay, so if it's a very important to understand, carry flag is set uh, after AAA because it adjusts AL and incrementing the AH. So that is the reason why carry flag is set. Okay, so now if you go to the condition, you can see here. So see the lower nibble, we know that our answer was 60, right? 60. So what we checked is the D is greater than 9. So what we need to do is our auxiliary flag equal to 1. This condition both if satisfied, then what we need to do is we need to add with the 6 we have done, right? Then we know that you have incremented AH, right? Two things is happening. AH will increment by 1 and your upper nibble, like a upper nibble of AL will be cleared. Then only will be getting a valid and packed decimal number, right? The 73, but this will be cleared after the AA process. Okay, so that's what they said here. Okay, if in other case, if auxiliary carry flag and carry flag is 0, so the higher nibble of AL is cleared, and to convert a ASCII value, and to do that OR it with 3030. So now we'll go to the program. See now the current after execution of AAA, what is the value in AH? 0103. Okay, now I am going to do the OR with the 3030. Why? To convert the equivalent ASCII value. Okay, so once you add with this, so what you'll get, you will be getting 3133, right? That will be value in the your AX. The corresponding, this is the corresponding ASCII value of 13. Okay, so this is a way how your AA instruction is working.